3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at NASA's plan for humans on the surface of the moon. Only a few days ago NASA returned the Space Launch System to the pad in preparation for the wet dress rehearsal. After a few complications in prior months, the system has been repaired and is ready to make progress. Along with this update, NASA also released information on some important upcoming launches, all of which are necessary, before sending humans to the moon. While it has been around half a decade since humans stepped foot on the moon, this is set to change not long from now. Artemis is making significant progress and the agency is working towards the first official launch of SLS. Looking at the Apollo missions and now Artemis, one of the biggest differences has to do with the plan and infrastructure on the surface of the moon. In Artemis's case, NASA hopes to pre-stage a lot of valuable equipment and also work closely with a handful of different commercial companies. They also have ambitious ideas for surface operations and more once they arrive. Here I will go more in depth into the agency's plan over the next few years and how they are trying to make this process work in the long term. When NASA sends astronauts to the surface of the moon, it will be the first time outside of watching historical footage most people witness humans walking on another planetary body. Building on these footsteps, future robotic and human explorers will put in place infrastructure for a long-term sustainable presence on the moon. In the past, NASA proposed a plan to go from limited, short-term Apollo-era exploration of the 1960s to a 21st-century plan in a report to the National Space Council. With the Artemis program, we will explore more of the moon than ever before to make the next giant leap, sending astronauts to Mars. After 20 years of continuously living in low Earth orbit, we are now ready for the next great challenge of space exploration, the development of a sustained presence on and around the moon, said former NASA Administrator Jim Bridenstine. For years to come, Artemis will serve as our North Star as we continue to work toward even greater exploration of the moon, where we will demonstrate key elements needed for the first human mission to Mars. NASA points out that on the surface, the core elements for a sustained presence would include an emphasis on mobility, to allow astronauts to explore more of the moon and conduct more science. Specifically, this includes a Lunar Terrain Vehicle or LTV, which would transport crew around the landing zone. Back in 2020, NASA issued two separate requests for information, RFI, seeking industry approaches for development of robotic mobility systems and human-class lunar rovers. With these RFIs, NASA seeks to foster an emerging American market of lunar transportation capability by engaging the terrestrial vehicle and robotic communities. First, the space agency is asking for concepts on robotic mobility systems to transport instruments across the lunar surface, conducting critical scientific research across wide areas of terrain, including areas where humans may not explore. As we return to the moon with Artemis, we are seeking new and innovative approaches that allow us to operate robotically anywhere on the lunar surface and explore more of our nearest neighbor than ever before, said Steve Clark, Deputy Associate Administrator for Exploration, Science Mission Directorate at NASA headquarters in Washington. We are turning to industry to offer us exciting approaches to leverage existing systems here on Earth, including law enforcement, military, or recreational vehicles that could be modified for use in space to enhance our mobility architecture. In order to expand the exploration footprints of the first woman and next man on the moon, NASA also is seeking industry feedback on relevant state-of-the-art commercial technologies and acquisition strategies for a new Lunar Terrain Vehicle or LTV. The LTV will be a human-rated, unpressurized, unenclosed rover that will be used to help astronauts explore and conduct experiments somewhere humans have never been before, the lunar South Pole. The most we can expect crew to walk while wearing their spacesuits is about a half-mile, said Marshall Smith, Director of Human Lunar Exploration Programs. If we can place a rover near a landing site before crew arrive, the potential for scientific return on those first missions will grow exponentially. The proof is in the past. The total areas explored for Apollo astronauts grew from a little over half a mile during Apollo 11 to 15 miles during Apollos 15 through 17. With the Lunar Roving Vehicle, astronauts were able to explore much more diverse geological features to maximize the science return of those missions. We also want to hear from industry leaders in all-terrain vehicles, electric vehicles, and more. This is not exclusive to the space industry, notes Smith. We want our rovers on the moon to draw on and spur innovations in electric vehicle energy storage and management, autonomous driving, and extreme environment resistance. Second, the habitable mobility platform would enable crews to take trips across the moon, lasting up to 45 days. Finally, a lunar foundation surface habitat that would house as many as 4 crew members on shorter surface days. Astronauts working on the lunar surface also could test advanced robotics, as well as a wide set of new technologies identified in the Lunar Surface Innovation Initiative, focusing on tech development in the areas such as of in situ resource utilization, ISRU, and power systems. Rovers will carry a variety of instruments including ISRU experiments that will generate information on the availability and extraction of usable resources, e.g., oxygen and water. Advancing these technologies could enable the production of fuel, water, and/or oxygen from local materials, enabling sustainable surface operations with decreasing supply needs from Earth. Another key difference from Apollo and Artemis will be use of the Gateway in lunar orbit, built with commercial and international partners. The lunar outpost will serve as a command and control module for surface expeditions, and an office and home for astronauts away from Earth. Operating autonomously when crew is not present, it also will be a platform for new science and technology demonstrations around the Moon. Over time, NASA and its partners plan to enhance the Lunar Gateway's habitation capabilities and related life support systems. Adding a large volume deep space habitation element would allow astronauts to test capabilities around the Moon for long-duration deep space missions. While the goal of Apollo was to land the first humans on the Moon, the Artemis program would use the Moon as a testbed for crewed exploration farther into the solar system, beginning with Mars. This is America's Moon to Mars space exploration approach. A proposed multi-month split crew operation at the Gateway and on the lunar surface would test the agency's concept for a human mission to the Red Planet. For such a mission, NASA envisions a 4-person crew traveling to the Gateway and living aboard the outpost for a multi-month stay to simulate the outbound trip to Mars. Later, 2 crew members would travel to the lunar surface and explore with the habitable mobility platform, while the remaining 2 astronauts stay aboard Gateway. The 4 crew members are later reunited aboard the lunar outpost for another multi-month stay, simulating the return trip to Earth. This mission would be the longest duration human deep space mission in history, and would be the first operational test of the readiness of our deep space systems. The report also highlights a robotic return to the surface for scientific discovery. The Moon is a natural laboratory to study planetary processes and evolution, and a platform from which to observe the universe. NASA will send dozens of new science instruments and technology demonstrations to the Moon with its Commercial Lunar Payload Services initiative. In this case, we have watched Firefly Aerospace continue to make progress on its lunar lander Blue Ghost as the mission gets closer and closer. Some of these robotic precursors, including the volatiles investigating polar exploration rover Viper, will study the terrain and metal and ice resources at the lunar South Pole. The Space Launch System rocket, or IN spacecraft, human landing systems and modern spacesuits, will round out the agency's deep space systems. As part of the Artemis 3 mission, the first human expedition back on the Moon will last approximately 7 days. NASA plans to send Artemis generation astronauts on increasingly longer missions about once per year thereafter. While the upcoming missions and tests in preparation for returning humans to the Moon is exciting, it also is an immense amount of work. A lot needs to be done and prepared prior to NASA creating a more permanent human presence off the planet. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.